Okay, ladies and gentlemen, in this video we're going to be talking about the circle theorems. Alright, in the circle theorem there are 5 rules that you need to remember, but first we got to start with labeling your circle. Alright, so first things first, this is the radius of your circle, just from the center to the external length of your circle. Okay, and then we know that 2 times your radius is equals to your diameter. Alright, so it is from one end to the other end that passes through your center. The external length of your circle is called your circumference, and then just part of it is called a arc, an arc. Alright, and if we're talking about the entire part of that circle, just partial of it, maybe this is 120 degrees, okay, then this is called the sector, and the tangent is the point that only touches the circumference at one specific point, just one specific point. Okay, so the first rule that we need to talk about will be your cyclic quadrilateral. So how does the cyclic quadrilateral rule work? The cyclic quadrilateral rule states that two opposite ends of your circle will add up to 180 degrees. So for example, x and y, x plus y will equals to 180 degrees, and this opposite a and b, a plus b would also equals to 180 degrees. Now if we were to give it an example for this question, say if we say this angle here is 56 degrees, then this angle would have been 180 minus 56, which is 124 degrees. Okay, and if for example we were to say this is 110 degrees, then this would be 70 degrees. Now note that a plus y does not equals to 180, neither will x plus b equals to 180. This is not true. Alright, so this is your first rule. The second rule would be the bow tie rule. So what does the bow tie rule say? The bow tie rule says that two angles subtended by the same arc, alright, these two exact same points are supposed to have the same angle. So this is x and this would be x as well. Now if we were to give an example for this, let's say we were to draw an example like this, okay, coming from the same two ends. Then if I were to say that this angle is 56 degrees, then this angle on this end would be 56 degrees as well. Now, like I mentioned just now, that it has to come out from the same two ends of your circumference. So if I were to draw another one like this, then this angle would have been x as well. So would this angle here. It doesn't matter where it lands on the circumference. As long as it lands on the circumference, then this is x, and so is this. These are all x. Alright, so if I were to draw here in the example, this angle here, doesn't matter wherever it lands, this would still be 56 degrees. Alright, that's your second rule. Your third rule is your arrow rule. Well, this is a name that we all make up by ourselves. But what does the arrow rule state? The arrow rule states that if this angle here is x, then the angle in the middle formed by the two radiuses that will pass through your center here would be 2x. Okay, so for example, if we were to look here, if this angle here is 30 degrees, or okay, maybe we need it to be like 70 degrees, then this angle would be 140 degrees. Okay, now if you continue to expand this two ends of your radius and you completely make it flatten out, then we know a straight line is 180 degrees. Now, if this is 180 degrees, look what we have here. Over here, we would have a right angled triangle here. Okay, so these are one of the rules that you need to remember. This will form a right angled triangle. Now, if you continue to expand these two ends, let's say this angle right now would be 250 degrees, then this angle in here would be 125 degrees. Alright, that's your third rule. Your fourth rule is the tangent rule. Tangent rule states that first things first, your tangent here, you only touch the circumference at exactly 1 point on your circle. Alright, same as here, exactly 1 point. If you were to combine these two tangents together, then these two would be the same length. This line and this line would be the same length, and remember that these two here would be the radius, which is still the same length. Also, when you form the tangent, this has to be right angled, so will this side and this side as well. These are all right angles. Alright, now your last rule, your fifth rule. The fifth rule is your alternate segment rule. The alternate segment rule states that this angle is the same as the angle subtended in here, and this angle is the same as the angle subtended in here. So if we were to look at an example here, if this angle is 112, now notice that it will not pass by the center. Alright, if this angle is 112, a lot of people will make the mistake that saying that this angle, a lot of people make the mistake that saying that this angle here is 112 as well, but this is wrong, because this is the direct neighbor of this angle here. So what it should be is this angle here instead should have been 112, and this angle over here would be 33 degrees. Alright, so these are the 5 rules for your circle theorem. Now let's look at an example. What kind of questions will come out in the exam? In the exam, they will combine all your rules together. Then you must be able to see what kind of rules to apply to find which angle. So looking at this question, A, B, C, D, E, F are points on the circumference of a circle center O. AE is the diameter of circle. BC is parallel to AE. Giving a reason for each answer, find angle BCA. So when you want to find angle BCA, it would be this point, and this point. So you're actually looking for this angle here. Alright, so we're looking for this angle here. Sorry, it was this point, and this point. So we're looking for this angle here instead. Okay, so since we're looking for this angle here, look at this. This is a parallel line and this is a parallel line. Applying our Z rule, where two parallel lines will form the same angle here, we know that this angle is exactly the same as 42 degrees here. So the answer is supposed to be 42 degrees, okay, because of the parallel lines. So you will just simply use your alternate angles that are parallel. Okay, now look at this next question. Angle ACE. Angle ACE, AC and E. We are looking for this angle in here. Now, if you were to look back in this triangle, you will see that the base of this triangle passes through the center O here. Maybe I should use a different color. Okay, this, and the base here passes through center O, making this angle 180 degrees. When we look back into the arrow rule, when the angle continues to open up here, we know that this angle is still half of this. So angle ACE would be 90 degrees. 90 degrees because of your arrow rule. Alright, it's passing through center O. then the reason would be angle ACE is half of AOE. Alright, now next, angle CFE. C, F and E, we are looking for this angle here. Now when we look at this angle, we should notice that it is the butterfly theory. Alright, this butterfly theory states that if this angle here is 42, then this angle would be 42 as well. Okay, so the reason would be alternate angles as well, I guess. Angles subtended by the same arc. Okay, now last one would be angle CDE. C, D and E, we're looking for this angle here. Alright, this angle here. Now look at this. If you were to look at this triangle, this polygon, this would have to apply your cyclic quadrilateral rule. Cyclic quadrilateral rule states that two opposite sides will add up to 180. So CDE would be 180 minus 42, which is 132 degrees. Using cyclic quadrilateral rule, opposite angles sum into 180 degrees. Okay, now one more example question from the past years. Find the value of x. GI is the diameter of the circle, FGH is the tangent of the circle at G, JK also lie on the circle, and angle JGI is equals to x, angle FGX 4x, angle KGI 2x. Alright, now if this is a tangent, then we know that these two sides are supposed to be right angles. This right angle contains 5x. 4x plus x is 5x, so it's supposed to equals to 90 degrees. Okay, so x will equals to 18 degrees. Alright, x is equals to 18. Next question, the size of angle J, K and G. J, K and G, we're looking for this angle over here. Now remember about your alternate segment rules. They say that this angle and this angle are supposed to be the same, because look, this is the triangle that is forming using your segment rule. So angle JKG is equals to 4x. 4x is 72 degrees. Okay, last question, the size of G, J and K. So we're looking for this angle here. Now since we already have the angles in here and here, we know that this is 354, then this is 72 degrees. Finally we can use 180 minus 54 minus 72, you would have gotten 56 degrees. Okay, sorry, not 56, 54. Right? Yeah, 54 degrees. Okay? Let me double check that with the calculator. Yep. So these are applying all your rules within the same question.